Welcome to the video, Information Flow Analysis. In the previous video we learned how to do domain transition analysis. In this video we'll use APOL and SE Info Flow for information flow analysis. Another analytical investigation of SE Linux policy is information flow analysis. Information flow analysis looks at how a domain could leak information toward another domain. Information flow analysis is performed by looking at all operations that occur between two types. A source type can be read by a domain, which subsequently can write information to another type. This simple approach is a two-step flow analysis. However, it's not as simple as just checking read and write operations. Information can be leaked through file names, file descriptors, and more. Information flow analysis must take all these approaches into account. Let's use APOL for information flow analysis. Once again, we'll load APOL. Go to File and click on Open Policy option. Click on Other Location, Computer, and go to the etc directory. Find the SE Linux directory and open the policy directory within Targeted. Now click on policy.30. After loading the SE Linux policy, go to Workspace, New Analysis, and select Information Flow Analysis as the analysis method. Type the source type as SSH home, and set all paths up to 3 steps. Also, give the target type, limit the results to 99, and click on Apply. Wait till it gets loaded. And here's the output. As you can see from this output, 99 information flow paths were found, after which the tool stopped as the results were limited to 99 in number, between SSH home T and DNS mask Q home T. The first shown flow informs the user that SSH home T content can be read by staff T domain. The DNS mask Q T domain is able to receive information from staff T and is of course able to append to its log files. To perform a decent information flow analysis, it's necessary to fine-tune the search criteria and most likely create a permission map as well. The analysis mode offers similar options as the domain transition analysis method. So, with shortest paths, the tool will stop processing a particular information flow, one between source and target, when a flow has been found. If there are multiple flows for the same path size, all these flows will be displayed though. With all paths up to, the tool will find all information flows up to a number of steps. Resource read by a domain or domain writing information to a resource for a given source and target type. Then the third option, flows out of the source type, provides a tree-like overview of all communication flows from a given type. Users can then browse through the various domains and types that information can flow to and continue analysing the flow further. The fourth one, flows into the target type, provides a reverse information flow analysis, starting from the target type and browsing upward to various source domains and types that can be eventually leaked to the target type. There are a few options that can be set for information flow analysis. Minimum permission weight allows users to only look at permissions or actions of a particular weight and higher. Each action is given a weight in the tool, from a low priority one, such as a lock operation, given the weight 1, to a high priority one, such as the write operation, given the weight 10. Then we have the limit results, which can have the tool stop after the given number of flows have been found. Next, excluded types allows users to remove particular types and domains from being part of the analysis. Trusted domains or types can as such be removed from the flow analysis, allowing users to focus on the less trusted types. And the last one, excluded permissions, allows users to remove permissions such as IOCTL, lock, and listen from the analysis. The last option allows users to manipulate the active permission map. In information flow analysis, creating a trustworthy permission map is an important and not to be underestimated step. The default permission map is available as perm_map within the SE Tools directory. In it, all classes are mentioned with all permissions. For each permission, the map informs the tool whether the permission is a read-like permission, write-like permission, dual channel, or not related to information flows. Next, a weight is given to each of these permissions. To limit the flow analysis to a particular set of classes, update the permission map and then rerun the analysis. Finally, let's use SE-info-flow for information flow analysis. So, the SE-info-flow application is a command-line application offered through SE Tools version 4, which offers information flow analysis capabilities like APOL. Every invocation of SE-info-flow requires a permission map to be passed on for its analysis. Although users can point it to the default permission map at per_m_map within the SE Tools directory, it's advised to use a custom permission map instead. For instance, when analysing non-network related information flows, administrators can create a permission map that excludes all classes related to network communication. As a result, the tool will exclude those permissions from being relevant in an information flow. As an example, let's look at the information flows between the SSH home T-type and DNS mask q var log T-type, given a custom map and using the shortest path approach, only using the maximum weighted permissions. We also exclude a few domains that are either not applicable or trusted. Let's type the command seinfo flow-m userlib 64/python 3.6 site-packages/se tools /per_m map -s ssh home t dns mask var log t -s -w 10 set files _t restore con d _t nfs d _t kernel _t. I know that's way too long, but it looks beautiful. Let's click enter. Wait for some time while it's being loaded. And here we have the output. With 99 flow information flows. Superb! In this video, we've looked at information flow analysis. In the next video, we'll be learning about other policy analysis.